So here is one of the boards. It's actually a spare board for that controls an 8x8 section of the display. It's missing a few chips and a few other things. So each 8x8 section has 8x8 RGB LEDs, and they have a common positive terminal and then a separate red, green, and blue negative. So each of these connects to the reds, greens, and blues of the columns, and this connects to the common positive of the rows. The circuit layout is basically identical to the Rainbow Duino project, with a few little differences. So the person who designed this board initially intended for them all to daisy chain together. So you have the plus 5 volt ground and the two I2C data lines on this side and that side, but as it turns out the power draw was too great and caused the 5 volts to dip down really far towards the end. So we ended up just having them connected in a tree fashion, so the other side, the power on the other side wasn't really used. Also, he forgot to put in a spot for a bypass capacitor. So, you know, ICSP header, FTDI, which we ended up not really using, reset button. The ATmega 328 goes here. It's not here. So here we have a parallel super source driver for the top, and then 3 shift register LED drivers for the negative side. So basically, it does one row at a time. So it will shift in the next row, switch this, and then disable the row on the old row here, latch in the new data, and then enable the new row. And it does that pretty fast. Now, a few design decisions that I think were not so great. Using I2C, obviously, you know, we didn't know a lot when we started making this, so we just copied the Rainbow Duino layout, or rather the Rainbow Duino design, and so we didn't realize that I2C was not really well suited for this at all. In fact, it's the worst choice, but we didn't feel like remaking all the boards, so I made it work. Having all of them be supplied with 5 volts tends to, you know, with the amount of current that this draws, 5 volts isn't really a good supply voltage to use. It would have been better to use 12 and then have a onboard buck regulator or something, or just these LED drivers, or rather the source driver and the LED driver supports higher voltage. These adjustable pots, as it turns out, the range isn't very good. They adjust the current for each of the 3 LED drivers, and as it turns out, if you have it up more than halfway, you're actually going way out of spec on these. So we have to be careful with that. And yeah, also I realized later on that these are 3 8-bit shift registers that are connected in a chain, and it realized that these are actually fast enough that we could have just chained all of them together. But you know, too late for that now. So yeah, that's the board. We currently have 6x3 with separate, I have it wired up for each, the left half and the right half to be separate I2C buses, so that we can get better frame rate. We can only get about 20 frames per second with them all on one bus. But as we can, but as we found out, that wasn't really as easy as we thought it would be. This is actually the project that made me buy an oscilloscope, because That was the only way I figured out that the problem we were having was that the I2C bus rise time was too long. Alright, well, that's that part.